everybody. And we are continuing where we had left off, examining the brain and functional parts of the brain. And then today we're going to get to, I believe it's chapter 12, where we're going to see integration of how these brain parts are communicating. And I'm sure we're not going to have time to get into the peripheral nervous system that is on the chapter 13. But then those parts that we don't get to cover here, I will cover the most important parts on Wednesday's lecture. And keep in mind that we only have these 2 lectures, right? It's like today and Wednesday. Yay! And on the following week, you will have the chance to take exam 4 or exam 5. Or if you prefer to take it on December 10th, you can come to class and take both exams on the same day. And Ray had asked me to put a QR code to do a little survey on how many people are going to show up for the exams next week in comparison to people who are going to show up on the 10th. And I forgot to do it. But I had a good reason. Playing fell off in my back. So, okay. But did you receive the email from Ray? Asking you, when you're going to take the test so we can coordinate like how many proctors we need in the classes and so on and so forth. So please make sure you respond to Ray's request so he can do a very good coordination with that. Okay. So here, coming to the functional areas. And this is really cool, right? I always like to study the brain because it's literally the brain is studying itself, right? And it's quite complicated. Right? The brain is very, very complex. So here we are looking at areas that are functional in the brain. And one thing that pops out at first is that you need your whole brain to work for you to think properly. So reasoning and thinking and everything that goes on in your head is involving the entire brain. Lots of areas in the brain. If you're thinking about certain parts of the body, you are activating your occipital cortex. You can imagine, you can do the visualization of the part. And you're doing prefrontal cortex. And you're also using speaking areas because you're thinking about the words, right? So entire brain is working with this association and thinking. But now specialized areas, like for example, when you have hearing sense sections, right? So those are going to be located very close to your ears, right? Actually, in contrast with visual areas, this is in the occipital lobe, okay? And speaking areas, there are two separate areas for speaking. And now we're going to also look at motor areas and sensory areas. They're very typical of brain maps. So first thing we're going to look here is at language areas. Okay, so you have to think and reason out what you're going to say. So your prefrontal cortex is involved. And right behind your prefrontal cortex, you have this area that is for motor speech. This is also called Broca's area. Anybody took psychology in the class? Yeah, have you seen the Broca's area before? Yeah, have you seen the accident with the, I forgot the name of that guy that had a construction pin that went through his Broca's area. That's like, I remember the accident, I don't remember exactly the details on that. But a lot of things changed in his life, especially his personality, because I think took part of his prefrontal cortex out. Amazing that the guy survived, right? Okay, so here, this area here is around Broca's area. So this allows you to speak making the sound of the words, okay? And then you have another language area here more to the back, and this is the Wernicke's area. Okay, this area allows you to interpret what you're going to say and to understand what the words mean. Okay, So this one allows you to speak the words. This one allows you to understand what you're saying and also what you should say. So here is a very simple representation of functional and structural parts of the brain. Yeah, I know this thing is kind of overwhelming, right? But we're going to break it down into pieces that you should know. So the first thing you should focus here, well, two parts that you should already recognize are these two parts over here on Broca's area, right? Motor speech, and this part here, the Wernicke's area. Okay, so these two parts we looked at. And now we are going to look at a very important landmark in the brain, which is the central sulcus, which is right there. It is going to be separating two lobes in your brain. Okay, it's going to be here for your prefrontal or frontal cortex. Okay, and this other cortex, which is your which cortex is that? Parietal cortex. My brain went blank. Okay, so separating two cortexes. And this central sulcus here is very, very prominent. It's a very deep type of indentation. Okay, so once you find here your central sulcus, you should focus in like to the front of the central sulcus. Okay, so this is the frontal part of the brain. Right to the front, you're going to have this gyrus here. There's a huge gyrus right there. And here is, of course, colored in red. This is a part that is very important for motor coordination in the body. Okay, so this is called the primary motor cortex. Okay, and it is going to be connected to parts of the body, to all the somatic parts of the body. So all of your voluntary muscles are going to have connections to this area right there. So this is your motor area, your primary motor cortex. Okay. So here, yeah, premotor cortex. So another area that is also very prominent here is right behind the central sulcus. So this is your primary sensory area. So it's called somatosensory cortex. Okay. And there are going to be correlations between the parts that you can coordinate to the parts that you can feel. So here you're going to feel parts in your body, and here you're going to command what those parts should do. Okay, so those are very important parts in the brain, the motor area and somatosensory areas. Okay. All right, so here, of course, we're going to look in more details on what these areas are doing. Here, I also have emphasized that you have areas in your prefrontal cortex, right? So prefrontal cortex, that are very, very important for decision making and for reasoning, okay, and memory. So we have working memory as well as long-term memory. And this area of the cortex is very much involved also with the problem solving and even with multitasking. Okay, so your prefrontal cortex, very, very important for these functions. Okay, so other areas that are quite important are over here. When you have the back of the head with your occipital lobe, that you're going to have your vision, primary vision and associated visual areas. So that's in the back of your head. Okay, and I always like to mention the example of Andrea Bocelli. Everybody knows who Andrea Bocelli is, the Italian singer. Yeah, who likes classical music? Yeah, who has no clue who Andrea Bocelli? No, never heard of him? You gotta check him out. If you like Italian music, he sings some songs in English as well. He's an Italian tenor, Italian singer, and he was born with vision problems like glaucoma, which is high blood pressure. But by the time that he was 12 years old, he was playing soccer, and he had an accident during the soccer game, and he hit the occipital lobe on somewhere after he got hit by the soccer ball, and he got bleeding in this area, in this occipital area. As a consequence, he became totally blind. And of course, there was nothing that could be done at the time to try to save his vision. I mean, his parents even went through unusual life-saving procedures, like using leeches, those worms that suck blood. Yeah, they put leeches on the back, on his brain, on the back of the head, to try to avoid internal bleeding and to try to keep his vision, but he became totally blind. So this is the area that got affected in his brain, and that's the area for vision. So here I have 2 points that is good for you to remember. I mentioned before, Broca's area and Wernicke's area, right? And those always make good test questions. And here comes your first eye clicker. And here we go. Let's get ready. Here is the eye clicker. All right. What part of the brain is location for your conscious mind? Now, everyone should get this one right. As a rule of thumb, if I did not mention some things yet, they should not be the correct answers. Did everybody send in the answer? Does anyone need more time? Yeah, you need more time? Everybody's so quiet. This is the part when you can cheat. I still have people giving me the wrong answers. Yeah. Okay, I'm gonna stop it. What is your answer? D is your cerebral cortex. That is the part you use for reasoning and thinking and all the good stuff that goes in the brain. So here are those very interesting gyri, right? Gyri is the part that bulges out. I always think of a gyro sandwich. Okay, so gyri, sulci are the parts that go inside. All right, so your primary motor cortex is also called somatic cortex, right? So remember that one is in precentral gyrus and is in the frontal lobe, right? Precentral frontal lobe. Before the center is precentral, right? So here is where you have this this notion of somatotopy. That means somatic function means you're going to coordinate your muscles, right? So all of the muscles of the body, they can be mapped to a certain area in your primary motor cortex, right? Now, how all your muscles are mapped, they have this strange distribution. So in order to get a better idea of which parts of the brain coordinate which parts of the body, scientists have drawn here the map of the parts of the body in relation to the parts of the brain that coordinate those areas. And this drawing over here, you call that the homunculus, or the little man. Okay? So look at this. If you look at the part that is getting close to the middle area of your brain, right? Opa. So I am not talking to spirits right now, so you can go some other time. Okay, so somatosensory cortex is not functioning in that side of town. So here we go. Look at this homunculus right there, right? And you see here, for example, a part that is related to your toes is a very tiny area, or to your foot is a very tiny spot in the brain. And then you look at here and you see, oh, the leg and the knees, they kind of have the same amount of brain as your foot. Okay, and then you look here, hip, trunk, shoulder, arm, elbow, wrist. Whoa, this is like a small part of the brain that is coordinating all of this area in your body, but the head is not there. Okay, and then look at this, your wrist and your hand and your fingers, they're totally disproportional, because the areas of the brain that coordinate these fine motor functions, they have to be quite large. Okay, and then you come here to the area that is coordinating your face and your mouth. Okay, so this is a huge area for coordination, right? Huge part of the brain. Look at this, it's equivalent to basically the area of your whole body that is coordinating your head and your face, right? And here you have also coordination for lips, right? And then your tongue gets its own special coordination area. Oh, the tongue is quite special, all right? It has its own spot over there, right? So this is related to every muscle that you can coordinate is in this somatic motor cortex, okay, in this gyrus. All right. Keep in mind that this gyrus coordinates the opposite side of the body. So the gyrus on my right side coordinates my left side. This is what you call contralateral coordination. Okay. So here you have your anterior part. This is the front of the brain. So here's a big gyrus. So the side that is on your right side coordinates your left side of the body, and then left side of the brain coordinates your right side of the body. So now here, in comparison to your somatosensory cortex, that's the blue guy over there, that's all the parts of the body that you can feel. Okay, so now we see, look at this, the part that you can feel from your foot is huge in comparison to the part that you actually coordinate some foot movement. Okay, so you feel a lot coming from your foot. And look at this, you have some special areas that I have highlighted that you can actually feel stuff, but you do not have corresponding areas in your motor cortex to coordinate those places in the body. Obviously, genitals, that's one part that doesn't have voluntary muscle coordination, right? And another part here is gums and teeth. You can feel something wrong with your gums and something wrong with your teeth, but you do not have muscles there. So, you know, there is no need, I mean, there is no reason to have coordination on the motor cortex. So you only feel stuff in those areas. And then there is this other area here, look at that, intra-abdominal muscles. You can feel stuff going on in your guts, but you of course cannot coordinate muscle contractions of any of that. It's a smooth muscle, right? But if something goes wrong, and let's say you have a stomach pain, you definitely feel that pain, right? All right, so everything else is more or less matched in size of the gyrus and parallel action. So here, you know, when you compare, for example, here, the area for feeling your fingers and feeling your hand is going to be side by side with the areas that you can actually coordinate those areas, those body parts. Okay. So what is important to know here? You are going to receive sensations from everywhere in your body. So that means the skin, you're going to feel pressure and you're going to feel pain. So you have proprioceptors, they're going to feel that, right? You're going to feel this information coming from all sorts of muscles, from skeletal muscles, also from joints and from tendons, right? And you're also going to process spatial orientation. You're going to know where your body is in space. Okay, so this is all related to your somatosensory cortex. And another question. We got tons of questions today. Okay. Which area of the brain is the staging area for skilled motor activities? So everybody should be very confident about this answer. Okay, Broca has to do with speech. It's not Broca. I'm asking the people who answered Broca. Thank you, Douglas. So they gave up the Broca. Anybody need more time? No. All right. What is your answer? B. Come on. All right. That is your motor cortex. And now we're going to start looking at association of different areas of the brain. So you have a lot of those fibers that are going from one side to another. So there are some fibers that you should keep in mind, pun intended, right? So association fibers, they are going to connect, let's see here, they are going to connect different parts that are in the same hemisphere of the brain. So here we have them in red. This is why everything here is color coded, okay? So here, association fibers, the same hemisphere of the brain, and then you have those red fibers, they are connecting here, connecting there. Those are called association fibers. And then you have some other fibers, they're called commissural fibers. Those are the ones in green. These guys, they are connecting the two different hemispheres of the brain. Okay, so left and right hemisphere, those are connected by those commissural fibers. Actually, these fibers is this bunch of fibers here. This is called the corpus callosum, connecting left and right sides of the brain. Okay, so those are the ones in green. And then you have another one here that are called projection fibers. Those are long fibers that are going to connect longitudinally. So the cortex, the top part of the brain, to the bottom part of the brain, and it's going to go to your medulla oblongata, and these connections are going to come down to the spinal cord. So going up and down, those are projection fibers. So two important places in projection fibers are these ones over here. This first one here that is in the white matter, okay, and it looks like this thing is irradiating from this central bunch of fibers over here. You call that the corona irradiata, radiata, right there, okay? So this guy over there, corona radiata, right here. Another part that is important for you to know is this bunch of fibers that are going all the way down here towards the pons and medulla oblongata. This here you call internal capsule. Okay, those purple fibers right there going up and down. Okay, so those are projection fibers. You're going to project what you want to do to the rest of the body, and you're also going to get information from the rest of the body. Here we are going to start looking at nuclei, a bunch of cell bodies, of neuron bodies that accumulate in certain areas of the brain. So nuclei is when you find things that are not white matter, but those are like deep within the brain. Okay, so what we see here is this basal nuclei, so we also called basal ganglia. Okay, and this is subdivided into several parts. It is deep in the brain, so it's under the cortex, so you call it subcortical, right? Under the cortex. And you have a lot of very important functions for these areas, right? Like what functions? When you have certain habits that you practice every day, also when you are applying yourself into learning something and retain the information, you're activating this basal nuclei, right? And you also use this area when you're dealing with emotional sensations. You activate some of those areas. So we're talking about cognition, discerning information, and deciding on whether some information is important or not. So you're doing filtering of all that information, and you put it all together with emotions. So it's a whole bunch of important stuff going on over there. Okay. So parts that are important in this basal nuclei. You have here the striatum. This is the green area over here. Now I don't remember where I got this this slide from. Is not from your book. Okay. So here you have the striatum. Now this, you have this area that is called the putamen, and the area that is called caudate nucleus is kind of a tail. Caudate is for tail. Okay, so caudate nucleus, putamen and caudate nucleus for your striatum. Okay, so this, yeah, this should be over there. Let me see, globus pallidus is this area over here, and inside the globus pallidus you have like external and internal. Subthalamic nucleus, this is a very important area, is under the thalamus. So here is the thalamus, and here is going to be your subthalamic nucleus. And then close to the subthalamic nucleus, you're going to have this area that is called substantia nigra. Okay, substantia nigra means black substance, which is right there. You're going to see on functions of those areas in a bit. So a few areas that you should know, right? So this area is deep within the brain, and that is called the diencephalon. Okay, so the diencephalon, where you're going to find it is between the cerebral hemispheres in the middle of the brain, okay, and is above your brain stem and is under your cortex. Okay, so important things about your diencephalon. You have three parts. Okay, you have thalamus, hypothalamus, and epithalamus. Okay, so of course you're not going to be coming out of the class as an expert on all these different areas of the brain, but when you hear a certain term in the brain, you should associate it with certain functions of that area. Okay, so thalamus is a most important center for relaying of information. Okay, so that is your thalamus. The thalamus is your friend. Is going to feel information that is coming from the body, coming from different areas, and is going to decide whether that information is important or not. Okay, so that is your thalamus. Besides that, it is also important in keeping you thinking. Okay, so your consciousness depends on thalamus function. On the other side of the coin, your sleepiness also depends on thalamus function. So being awake or being asleep, those are functions of your thalamus. All right. So thalamus, very, very important for relay of information and deciding on what to do. And then you have this other guy here, your hypothalamus, under the thalamus, right? Hypothalamus. That guy is so important for maintaining body functions in relation to homeostasis. That means if you're feeling hungry, that is your hypothalamus telling you that you are hungry. If you're feeling thirsty, that is your hypothalamus reminding you to drink something. Hypothalamic action. If you are feeling cold, that is also your hypothalamus telling you to put on a sweater, right? Now we're gonna get a cold front, and you know, don't go out and freeze. I mean, this is Florida, you're not gonna freeze, but anyway, it's your hypothalamus. When you get sick, especially with a bacterial infection, and you develop a fever, that is your hypothalamus responding to signals that came from the infection site. So signals are cytokines. Okay, so hypothalamus is your thermostat. So if you get a fever, the hypothalamus sets off your thermostat to make your body generate heat. At the same time, it makes you feel cold, because if you bundle yourself up, you're going to generate more heat. Hypothalamus is very smart, right? It wants your body to be hotter, it's going to make you feel cold, although you're really hot, burning, hot with fever. Okay, all about the hypothalamus. All right. And look at this, it's also important for hormonal production. Yeah, hypothalamus is the thing. All right. The hypothalamus is going to be connected to your pituitary gland. Okay, so the hypothalamus is going to make some hormones and send it to a part of the pituitary gland, and is also going to coordinate whether the other part of the pituitary gland is going to release hormones or not. It's all hypothalamic action. Okay, pituitary gland is mainly the holding of those hormones. All right. So very important for endocrine function. All right. So thalamus, hypothalamus, and then you get here your epithalamus. It's kind of like in the back of those two. In the epithalamus, you're going to find your pineal gland, right? So in this diencephalon, you're going to have your pituitary gland. You're going to also have your pineal gland. Pineal gland is very important for production of melatonin and in regulation for sleep and awake cycles. Have you seen these over-the-counter melatonin pills or gummies or something, right? And those, I mean, if you take some melatonin, you're going to be feeling sleepy like a few hours later, right? Some people take melatonin like half an hour before going to sleep, and they wonder why they cannot fall asleep. Yeah, I would say don't take melatonin if you don't have to. Some people are very sensitive to melatonin, some other people are not, right? But if you can avoid taking melatonin, it's a good thing. So your pineal gland works on its own. One trick for a good sleep hygiene is to wear those blue light blockage glasses. You know those orange glasses? Yeah, even if you do not wear prescription glasses, if you wear those at night or as soon as the sun goes down, that sends a signal to your pineal gland that you should get closer to sleep time. If you have those fluorescent lights on, or if you're in front of the computer, that's totally going to mess up your pineal gland. Totally. And if you're on the phone, like guilty, I'm like catching up with all the story that happens during the day. I'm on the phone like until I don't know what time. You're like, oh my goodness, I got to sleep. Yeah, it happens to everybody, right? But that totally messes up your pineal gland. All right. Okay, so diencephalon is very important for integrating a lot of sensory and motor pathways, and also on deciding what the things that are important. Right? All right. So here, your diencephalon. You see another thing to emphasize, what are the parts of your diencephalon. So here you have your hypothalamus. Here you have your thalamus. And over here, you're going to have your epithalamus, like around there. Okay, so this whole thing here is your diencephalon. And then it should also include your pituitary gland right there. So yeah. Stretch this thing right here. There you go. That's your better diencephalon. Okay. So a bit more on functions of those parts. Okay. So here, looking at the epithalamus. Okay, you have your pineal gland right there. It's a small little gland. I think it's the size of a lentil or a pea. Not much bigger than that. Okay. Again, this is a part that is going to produce melatonin, okay? And you are going to use this area in the epithalamus to send signals that are going to be connected to other parts of the brain, especially from the limbic system to the midbrain. But I want you to remember, pineal gland and melatonin for this part. Okay, so here is your thalamus. Okay. Here's your thalamus, and this is the very, very important part that is going to distinguish what is important from what is not important in your brain. So integration and assimilation. Thalamus is going to decide what goes up to the cortex, what goes up to the cerebrum part, to the cerebral cortex, right? So we're going to see more of this in a little while. Okay. And then here's a picture of your hypothalamus. You have several nuclei in your hypothalamus, and of course you don't have to focus on knowing those, right? But know that there are several areas here in the hypothalamus. Okay. Hypothalamus is going to produce a lot of hormones, and the hypothalamus is going to coordinate what goes on with your autonomic nervous system. Okay, a lot of stuff that's going on here that is produced automatically, and hypothalamus is a part, is the responsible for that. One thing that you should know here is this connection here of your hypothalamus to your pituitary gland. There is this part right here that is connecting these two areas, and that is called the infundibulum. Okay, so this is the track connecting hypothalamus to your pituitary gland. Yeah, lots of strange names here. All right. So here we're going to start taking a look at the limbic system. So once you think about limbic system, you should start thinking about sexual arousal. That's a good thing to remember. A limbic system, right? Everybody remember that one. So what is going on here? Not only is going to coordinate sexual behavior, but you're also going to be coordinating what you're going to remember and how you're going to process all the information, okay, and emotions and all of that good stuff. Okay. So this is all making your limbic system. Okay, so here a bit more on your hypothalamus, right, that I just mentioned this. And this is just written out so you can study on what are the important parts that you remember about the hypothalamus. No, do not worry about remembering every single nucleus that is on the hypothalamus. That's insane. But know that you have a lot of nuclei over there. Each one of them is doing a different thing. Okay. So this is FYI. Okay, don't panic. All right. All right. So now let's go a bit lower, and we're going to hit the brainstem. So the brainstem is made up of 3 parts. You're going to have here the midbrain, you're going to have the pons, and you're going to have your medulla oblongata. That's just before your spinal cord. Okay, so 3 parts for your midbrain. And I always like to ask this question: what are the 3 parts that make up the midbrain? Yay, test question, clue. Okay. All right, so here, your midbrain, let's see what is important to know about that. You are going to find in your midbrain certain nuclei that are very important for origination of cranial nerves. And you're going to find here this area that looks darker than the other areas. And this is the part you call substantia nigra, okay, substantia nigra, right here. This area has neurons that use and generate and release dopamine, right? And when neurons in this area are not functioning properly, that's when you start getting lack of coordination of movement, and those are very much associated to Parkinson's disease. So this substantia nigra here, when neurons degenerate, this is when you get Parkinson's. All right, so two sides here, substantia nigra. Okay, so, oh, look at that. I just gave you the answer to the next question. So if you are awake and your thalamus is working properly, then you should get the answer to this question very quickly. Just by elimination, you should get the right answer here. Does anyone need more time? Everybody answered? Yeah, yeah. Okay, what is your answer? A. Substantia nigra, you think dopamine. You think problem with dopamine is Parkinson's. And then we're going to look here at the pons. Okay, so here you have this area for the pons. You also have origination of other cranial nerves. And what is important here to know is that you have a lot of coordination and relay of information about motor function, sensation, eye movement, hearing, tastes, and special senses. Right, this is all happening here at the pons. What is the function here? Is between the brain stem. Okay, is bridging the brain stem to the rest of the brain here. So brain stem over here, pons over there. Okay. It's going to send signals to the brain, and is also going to get signals that are going to go back and forth from the cerebrum, that's the main part of the brain, to the cerebellum, which is right behind the pons over here. Here is the only little part of the cerebellum. Okay, brain is up there, cerebellum is going to be right behind over there. Okay. Important functions of the pons, they are going to coordinate centers for breathing. So if you have damaged neurons in the pons, you cannot regulate breathing, and especially unconscious breathing, well, as well as conscious breathing. So the pons is very, very important for that. Okay. And then we come to the lower part, your medulla oblongata. Okay, here pons up there, medulla oblongata goes in here. And this is the part that's going to coordinate the rest of the brain to your spinal cord. You have other cranial nerves that are going to originate from the medulla oblongata. And you have certain center areas that are going to coordinate heartbeat and functions of circulatory system, meaning vasodilation, vasoconstriction. And you're going to also have areas that coordinate breathing, both conscious and unconscious type of breathing. Very important area in the back of the head. Okay. And then we get here to the very back of the head, and you find your cerebellum. This cerebellum is really, really amazing. First thing that you're going to see when you have a cross section of the cerebellum is that it has these formations that look like a tree. So this is what you call your arbor vitae, and this is part of your homework, right? So you see a little tree formation with a lot of gyri and sulcus that are very prominent. It looks like a little brain. That's why it's called the cerebellum. It's a little brain in the back of the head. And the distribution of matter follows the brain distribution, in which you have gray matter on the outside and white matter on the inside. Okay. An important thing, this is a very interesting thing here. Okay. This is really a major structure of the brain, and yeah, it's before the brain stem, okay, and is under the occipital lobe. Remember, occipital lobe is for vision. And I have a very interesting thing. I think it's the next, yeah, right here. Look at this. The cerebellum is a small part in the back of the brain. It's only taking about 10% of the brain volume, okay, the whole brain volume. But look at this. More than 50% of the neurons are located in the cerebellum. This is a huge disproportion in comparison to the rest of the brain. Okay, so 10% of the volume takes more than 50% of all of your neurons. Now, that area of the brain is important for many, many things. Let's look here first at the anatomy of the cerebellum. Okay, so you have two hemispheres here of your cerebellum. Okay, so left and right hemisphere. And between them, you have this dense area that you call the vermis. This is the part that connects the right and the left cerebellum. Okay, so vermis is connecting these right and left sides. And then here, the things that are important that the cerebellum is doing. Okay, first thing is sense of balance and coordination. So if you like to play sports, you're really activating your cerebellum. If you have good hand-eye coordination, that is also your cerebellum, right? And balance. And it's interesting that a lot of those neurons can be affected by commonly used drugs. Anybody can tell me one drug that affects? Alcohol. Yeah. You know those guys that if you're driving under the influence, the cops stop you, and what is the first thing they tell you? Oh, I don't know. I was never stopped, but I heard there was like walk a straight line, right? You go like this, and you walk a straight line, and if you're not under influence of any alcohol, you can actually walk this straight line. Okay. And then you're going to tell me something like this before, right? Or touch your nose without thinking, without looking. Anybody close your eyes, touch your nose? That's your cerebellum in action, right? Okay, so all these nice coordinated functions have to do with cerebellar work, okay? So cerebellum is going to receive information and is going to process information and coordinates information that have to be sent to other areas of the brain, including the midbrain. So first it's going to be passing through the cerebellum and then going to go to the midbrain, and then maybe information going to go to cortex, and then you're going to decide on what to do, and there's a lot of relay information going on here. All right. So with that, then you're going to go from the medulla oblongata, you're going to go to the spinal cord, right? So here is actually just showing the vertebral column. Is not definitely showing the spinal cord. Well, the spinal cord is going to come all the way to here, not all the way down to your vertebral column. Okay, it covers about 2/3 of the length area. Okay, so you're going to have a lot of spinal nerves that are going to come out of your spinal cord. Actually, you're going to have 31 pairs of nerves that are coming out from the spinal cord. Yeah, I should have a better picture for this. Okay, so with that, we are going to go into the next chapter. That is the chapter 13. Unless you have some minutes to talk about good stuff on chapter 13. Okay. So this has to do with peripheral nervous system. Okay, so you are going to get information from the outside of the body, and you're going to feel what that is happening and decide on whether you're going to cause some motor function to take place or not. Okay, so for the peripheral nervous system, you have two types of nerves. Right, so you have nerves that are going to go to the central nervous system. Those are called afferent nerves. You remember arriving, so afferent for arriving nerves, arriving to the CNS. And then the nerves that come out of the CNS and go to the periphery, those are your afferent nerves, so E for exiting. Okay. So important things that are functions of peripheral is related to sensory information, and of course motor ending. All right, so this I took from that study session from your book, from the study modules in the book. I think this is very well explained and has a good worksheet for you to practice the things that are important to focus on. Right. So here they have here. Basically, what is the peripheral nervous system is everything but not your central nervous system. So all of the nerves and all the neuronal structures that are outside of your central nervous system, you call that peripheral. Okay. So information that goes up and down from peripheral to central nervous system has to do with sensing stuff, so your sensory receptors. We're going to see which type of sensory receptors those are. Okay, and mainly you should think about nerves that are coming and nerves that are going, as we mentioned, afferent and efferent nerves. So here is that information, that example showing that if you are lighting a match and you're holding it for a bit too long, You're going to have nociceptors. Those are pain signals on your skin. And that is going to send a signal to your peripheral nervous system that is going to alert your central nervous system that something is happening. And your central nervous system should say something like, move your hand, otherwise you're going to really get burned, right? So this would be an example of a reflex reaction. And that, really goes from peripheral to spinal cord and then back to moving your hand. But it still has to go to the central nervous system to decide on what to do. Another question. Which of the following does not require the use of the peripheral nervous system? All right, this is an easy question. I don't think you need more than 30 seconds to answer that. So what is it that you can do without using your peripheral nervous system? Does anyone need more time? No? Okay, what is your answer? B, thinking. By thinking, you're not using your peripheral nervous system. If you answer anything else other than thinking, you come and talk to me. Okay. All right, so what is part here of your peripheral nervous system? You're going to have stuff to feel things. So those are sensory receptors, all different types of them. Okay. Then you're going to have transmission lines. They're going to bring the feeling to somewhere else, right? Then you're going to have motor endings. They're going to coordinate some kind of motor response. Besides all that, you also have those reflex actions. So when you put your hand on a hot plate, you don't have to feel, sometimes you'll move your hand from the hot plate even before you have that sensation of the heat that gets to your brain, right? And this is when I have that example that, I gotta tell you about that personal example of reflex reaction, right? Like I like to ice skate. So I was learning this new move. Who likes to ice skate? Ice skate in the class. Yeah. Some ice skate enthusiasts. Yeah. Figure skating, yes. And I was part of the synchronized team last year. Yay. It is so difficult to do synchronized skating. No, it is so weird. I mean, when you're skating by yourself, you make a mistake, nobody notices. You're doing synchronized skating, you make a mistake, everybody notices, right? But anyway, so I'm there learning the mohawk. You go from one foot to the other, no problem, 1 foot to the other, try to go the other way. Left foot to right foot, my cerebellum did not work properly. I fell right on my coccyx. You know what I'm talking about? Between the ischiums? Yeah. I heard the fall. And then I saw another coach that went like, and then I felt the pain. It took a few seconds. That was some pain. I think I saw the entire set of constellations of little stars flying. That was painful. But that was interesting because I hit the floor and then I see the reaction and then the sensation came to the central nervous system. That was so cool. I said, that's a good example for anatomy physiology class. Okay, so what is happening over here? Okay, sensory pathways, somatosensory. Okay, when you talk about somatosensory system, you are mainly talking about things that are happening in the body wall, not inside of the body. So body wall, on your skin, and also on your limbs. So this is all part of your somatosensory system. So besides all that, you also have a special senses type of system. That has to do with vision and hearing, and also taste and smell. So special senses, right? And also the feeling of equilibrium is also incorporated into the special senses. You have special neurons that do special senses, right? And then you have this other subdivision here that is called general senses. So a lot of your receptors, they're basically simple receptors, they are part of this general type of senses. And what is it that those receptors are including? They're including touch or pressure, right? And pain, so those are going to be your nociceptors. I like to call them nociceptors, like nocireceptors for pain, right? Nociceptors. Then you're going to have temperature sensors, also vibration type of sensors. And what is proprioceptor? Balance and notion of where your body is, where in space your body parts are located. Like you don't have to think that your foot is down there, because you have this proprioceptor that will tell your brain that your foot is down there. If you put your foot up there, your proprioceptor will notice that your foot is not down there anymore. That's the type of sensation that you have, is based on proprioception. Okay. So how is this getting coordinated? Okay. You are going to get the information that is coming from all this sensory stuff, and you're going to push it to your peripheral nervous system that is going to coordinate or not with your central nervous system. Okay? And then other things are going to happen. Once you have integration of the sensations, you are going to have decisions that are going to come out of that integration, and either you're going to activate some somatic response, or you can activate autonomic nervous system. Okay, you can either activate somatic response, or you can activate some autonomic nervous system response. And it still gets a bit more, you get a little more options when you activate your autonomic nervous system, because here you can have the response there subdivided in two other ways. You can either have a sympathetic type of response or a parasympathetic type of response. Okay, so what is happening here? At first, you're gathering the information, you're pushing it to your peripheral system, and from here, you are going to have communication with CNS, and either you do motor, or you do autonomic, or you do both. Okay, so let's see here on sensory discerning and responses. Okay. So let me see what we need to focus here. All right, so types of receptors that you have. Okay, so those you absolutely have to know. This is very simple. You read the word, it tells you what the receptor is doing. Okay, so if you read something that says mechanoreceptor, what do you think those receptors are doing? They are feeling pressure, stretching, and touching, or vibration. So that's the job of mechanoreceptors. And then you have some other receptors that are thermal. Of course, that has to do with the temperature. Then you have photoreceptors. Where are you going to find those? In your eyes, right? Photoreceptors in the retina. Then you have these guys over here, chemoreceptors. I think chemistry stuff. You should be thinking about smell, taste. But besides that, because those are special senses, you also have change in your blood chemistry. Like, for example, when you have too much carbon dioxide in your blood, you have sensors strategically placed in some arteries. They're going to feel that excess of carbon dioxide, and those sensors are going to send information to your brain that is going to tell your body to breathe faster. Okay? When do you have elevated carbon dioxide in the body? Well, maybe if you forget to breathe, but most likely you're not going to forget to breathe, but you could be exercising, right? You're burning those calories, you're producing carbon dioxide. So those chemoreceptors are going to feel it, and they're going to send information to what to do to adjust for the change in the homeostasis, the homeostatic imbalance. All right. And then you have the naughty guys here, the nociceptors. right? That has to do with pain, okay? And pain is not just, common feeling of pain, like for example, if you step on a rusty nail, right? It could also be extreme heat or extreme cold. That is also pain, okay? Or inflammation or other kind of stuff. All right, those are receptor based on what they're doing. And then you have other types of receptors based on where you find them, okay? Look at this. These guys here are external, so those are the outside, close to the external part of the body, right? So they're going to feel things that are coming from the outside. External receptors. Then you have the other ones that are internal receptors. They're going to feel stuff that is in your gut, right, from the inside of your body. So you have coming here. It's outside of the body, this coming from the inside of the body. And then you have those other guys, they are the proprioceptors, and those are going to feel things that are still happening in the inside of the body, but it's not part of the gut. Okay, so those are going to give you the idea of balance and where your body parts are and how much you are putting pressure on some joints, right? So you have all those proprioceptors. So 3 types of receptors based on location. Okay, so you got to know all those guys here. All right, now we got to the fun part. Sensory processing, like how you're going to feel what you are getting the information and how you're going to interpret the information. Right. So sensation. You have to be aware of stuff that is happening outside or inside, and in comparison here to perception is how you're going to interpret what you have just received. Okay. All right. So here's when we start talking again about the limbic system, because that will really decide whether you're going to feel something or not. All right. So your peripheral nervous system is going to send information to your limbic system, and especially at the thalamus, it is going to decide on whether you should feel something or you should just ignore something, ignore some information, right? So your thalamus is going to decide whether the sensation is something important or not. Okay. So here, looking again at your limbic system, again to those different parts that I have briefly mentioned, just to have an idea of the anatomy. So now we're going to get a bit more idea of the function of those parts, right? I don't think I had mentioned the amygdala before, but the amygdala right here is very, very important and is part of your limbic system, okay, close to your caudate body, okay, is very important because it's going to be involved with a lot of primordial feelings or primitive feelings. Like you're going to process emotions there. And if you feel afraid about something, that's your amygdala telling you to be afraid, right? If you are angry about stuff, that is your activated amygdala, right? Saying that, well, you are afraid about something, so be angry about it too, right? Insult to injury kind of thing, all right? But on the other side, if you really like something, if you have a lot of pleasure in some activities, that is also your amygdala telling you to go ahead and enjoy it, right? So amygdala is a kind of confused thing. Okay, good thing, bad thing, everything is going through the amygdala here. Besides all that, you can have the amygdala to help you to remember things that are associated with all those feelings, right? Oh, you're afraid about a test. Amygdala is activated. I better remember this subject. Otherwise, I'll flunk the test. Fear, right? Activation of your amygdala. So after the amygdala here, then you have your hippocampus, and that should be around, where is the hippocampus? Right? No, that's hypothalamus. Hippocampus right here. Okay, that's your hippocampus over here. That is also going to be involved in formation of memories, and is going to be activated when you need to coordinate certain movement in relation to space. Okay, and of course that is going to coordinate with your cerebellum as well. Hippocampus is important when you are transforming short-term memory into long-term memory. Okay, you have certain neurons in your hippocampus that have mechanisms that allow you to store long-term memory. Okay, so when you shift something from just learning to learning long-term, that is action of your hippocampus. Okay, so amygdala, hippocampus. All right. Your hypothalamus, we talk about your hypothalamus right there. Remember, close to your pituitary gland right here. So here is your hypothalamus, right? As I mentioned, is very, very important for control of homeostatic balance and automatic or autonomic nervous body function, okay? And it is also involved in emotional intelligence and emotional response. So this is cool because your amygdala tells you to do something with a gut feeling and just get angry, get fearful, and then your hypothalamus will tell you to not act right away on those feelings because you have a higher processing center that can distinguish whether you should or not act on those fears and feelings. Right? So your amygdala is going to talk here to your hypothalamus. All right. Then again here, you get to your thalamus. That's a very, very important area that is going to decide whether you're going to feel something or not. So example here, quick example that I'm going to give you on the thalamus is that all the sensations that are coming to your body all the time, they go through the thalamus. And it does such a good job distinguishing what is important from what is not important that you totally ignore what is not important if you have this area of the brain working properly. Okay, so an example now is socks. Everybody or most people are wearing socks. Are you feeling your socks or shoes? Okay, everybody wearing shoes? No, you are not feeling your shoes until I mention about your shoes. So now your conscious mind focus on your shoes. Now you feel your shoes, right? But your thalamus was telling you not to feel the shoes. Another thing is the seat. You are sitting on your ischiums, right? And you did not think about the sensation of that seat until we mentioned, and you bring your attention to that sense. Yeah. Everything. Yes, everything. All the sensation gets severed or gets processed as important or not in your thalamus. Yeah. Yeah, yeah. When you're so concentrated that, yeah, that's another example that actually happened today. I don't have a lot of time to cook, so I put some more eggs to boil, and then I went and looked in the PowerPoint, and I totally forgot about the eggs. Yeah, totally. That was not important anymore. So the thalamus kind of like got so focused on the task that, yeah, those eggs and the pan is totally ruined. But hey, that was not important at the time. Okay, so all this filtering of what is important or not will go through the thalamus. And also this is an area that has a divergent way of neuronal connections in people who have autism spectrum disorders. Okay, have you heard of autism? A lot of people have autism. Yeah. 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 That's exactly why I mentioned socks. Mm-hmm. Mm-hmm. Yeah, and sorry that I triggered the socks memory because, yeah, because I also have some issues with sensory input, right? And I had no idea why I was different from my classmates when I was growing up in Brazil in the 70s because there was no such thing of knowledge of autism spectrum disorders, right? But then when my son was born and he had those issues, and I took him to be evaluated, and I was looking at the questions, I'm like, oh my God, that's me. And I never knew it. And I could never wear those socks with the seam to the inside. I turned them inside out. Then I can tolerate socks. Yeah, it's amazing how those sensory inputs don't get filtered out, right? But we can work with it instead of just saying, what the hell, no? That goes through the thalamus, right? Okay, so parts that you should know here. You should definitely know where your hypothalamus is and where your thalamus is. And then you get these other areas here. Can never say this. Cingulate gyrus. Where is here? Cingulate gyrus. Big part of the brain right here. Still subcortical area. Okay. You are going to have emotional processing, emotional regulation, and creation of habits that are going to activate that part of your cingulate gyrus. Okay. You have another area here, your olfactory bulb. Where is your olfactory bulb located? Oh, right behind your nose. Remember, you have nerves that go directly from the nose to the brain. That's through your olfactory bulb. Not only you're going to sense smell, but you're also going to have connections between smell and emotions. Okay? So I like to give the example of if you went through some traumatic event in your life, like, I don't know, you had some elementary school teacher that was really mean and you couldn't stand the teacher. The teacher was always wearing that one perfume, right? So now, I don't know, 20 years later, if you smell that perfume, you forgot about the teacher, but if you smell that perfume, you're going to go, that teacher, right? So there is a connection between your olfactory bulb and your memory centers and your emotional memory centers. On the other hand, if you had a girlfriend, they wear that perfume, you know, and you're sitting on the side, besides that the classmate, they had the mean teacher, and then the person passes, you know, with that perfume, that guy who had the girlfriend that wore the perfume is going to be, oh my goodness, that's such a great memory. And the other guy's going to go, the teacher, right? So it depends on what you associate with the smell. You're going to have either positive or negative associations or responses. But the smell itself didn't do anything, but the reactivation of those memory centers that had to do with emotion when you smell something, that is what is happening. Okay. Now it gets even more interesting. All right. All right, so when you're looking here at what is happening with the sensation of those feelings, right? First thing, you have to feel it. You have to have the receptor that is going to be activated. Then you're going to have to process it. And then you're going to have a response that is going to come after the processing of that pathway. Okay, let me just make sure I'm not blowing the time here. Okay. So I am going to stop in this slide, and then most likely